Hello everybody. So today we're going to finish up section 0.4 or section 7.4, which if you remember from last week, we took a look at solving systems of equations using algebra, specifically the substitution method. So as a quick recap, the example we did last week, we had two systems here, or we had one system with two equations. And what we did is we took one of those equations and isolated a variable. So here we isolated the x variable. And then what we did is we took that x variable and put it in to the other equation, which was this one here. So we got x by itself. It represented negative 2y plus 2. So we came up here to this x and made that x negative 2y plus 2. Simplified it. We only had one variable there. So all we had to do was isolate for that y variable. We had half our solution, which was 5. And then we can just put that y into either of the two equations. And then all we have left is an x. So then we can just isolate for x and get x. So what we're going to do today is I'm going to show you two examples. The first example is using what we learned in section 7.1, which was developing our own system from a word problem. And we're going to do that now, and then we're going to solve it. So we're combining 7.1 skills with the skills from 7.4 to solve. And then we're going to do another example that involves fractions. And there's a nice trick that we can use with fractions to make our job a little easier. And I'll show you what that trick is later. Okay, so what we're going to do is the first one, a word problem. So what this one is we're going to have Nuri make two investments. Made two investments. Okay, totaling $2,000. So total, she put in $2,000 into the bank. Okay, so one at an annual interest rate of 10% and one at 8%. Okay, so after 1 year, the interest she earned is $190. And the question is, how much was invested at each rate? Okay. So what do we got to do? We got two variables here. We got two bank accounts, two different interest rates. So ultimately, we want to set our x and our y to be equal to what we're trying to solve for. So we're trying to solve for the money, the amount of money that went into the 8% investment, and also the amount of money that went into the 10% investment. Okay, so what we're going to say is we're going to let x equal the amount of dollars that went into the 8% account And we're going to let y equal the amount of dollars that went into the 10% account. Okay? You don't want to set your variables as something that you're not looking for, because once you find them, if it's not what the question's asking for, then you haven't answered the question, right? Okay, so X is the money we put into the 8% account, Y is the money we put into the 10% account. So what do we know about these two values from the question? Well, we know that both X and Y together have to total $2,000. She only put in $2,000 combined between both these accounts, so we know that X and Y together have to add to 2,000. So how do we put that down in an equation? Well, it's pretty straightforward. All it's going to be is the amount of dollars from the 8% plus the amount of dollars from the 10% have to equal 2,000. Whatever money she put into X and whatever money she put in Y, together they have to be 2,000. And the other thing we know is the interest that she gained. She gained $190 in interest. So how do we find interest? Well, the interest is just the interest rate as a decimal. And then if we want to find the interest, we take that interest rate and multiply it by the money in the account. So if we want to know the amount of interest from the 8% account, well, that's going to be 0.08. That's 8% as a decimal. And we just multiply it by the amount of money that was in that account. Well, what variable are we using to represent the money that's going into the 8% account? It's X. So we're going to put 0.08x because we're multiplying it by that interest rate, that 0.08. Which, of course, if we extend that thinking to the 10%, well, 10% as a decimal is just 0.1. Multiply it by y, because that's the amount of money we put into the 10% account. And total, it has to equal $190 because that's the interest rate we got, or that's the interest that we got from the investment. So now we have a system. We have two equations that are true for the question. And now we just want to solve for x and y, so we can use our substitution method. So remember, it really doesn't matter which variable you choose to isolate here. You can isolate x or y in the first equation. You can isolate x or y in the second equation. You will get the same answer regardless. But remember what I said last week. If you have a variable in either equation in your system that does not have a coefficient, it's going to make your life a lot easier. That's one less step of arithmetic that you have to do in your method to get to the answer. So if we take a look, actually there's two variables that don't have coefficients here. This x does not have a coefficient, and this y also does not have a coefficient. The other x and the other y does. So what I would recommend is to either isolate for x or y with the first equation. It's going to be a little easier. It's going to take less steps. So what I'm going to do here is I'm going to begin my substitution with the first equation. So we'll do x plus y equals 2,000. And I'll just isolate for x. It doesn't matter. Like I said, you could isolate for y if you want to. So if I want to get x by itself, the only thing that's stopping the x from being by itself there is the y. We want to move the y to the other side. It's x plus y. So if we use our opposite operation to move y to the other side, that of course is going to be subtraction. So we got to subtract y on both sides. Whoops. When I do that, of course, the y's cancel. All I have left on the left-hand side is my x. And on the right, I just have 2,000 minus y. Okay, so I have one variable there that's isolated. So now I'm going to take my other equation, which is 0.08x plus 0.10y equals 190. And because what I have here says anytime I see x, I can write 2000 minus y, and every time I see 2000 minus y, I can write x. Well, I see an x right over here, so I'm going to change that x into a 2000 minus y. I'll write my substitution in red just so it's clear. And now if you look carefully, we only have y in this new equation. So now we can solve for y. So we just have to use our algebra for this now. So I'm going to begin by using my distributive property right here. So if you write that out, let's see here. So that's 2000 times 0.08 gives you 160. And then that's going to be minus 0.08y plus 0.10y equals 190. I have some like terms right there I can combine. So that's going to be plus, what is that going to be? 0.02y, right? Equals 190. I want to get that y by itself, so I'm going to take care of this 160. That's a positive 160. So if I want to get it out of the way, I'll subtract my 160 on both sides. Of course, this cancels here. So I have 0.02y on that side. 190 minus 160 just gives me 30. And then the last thing I want to do, that's 0.02 times y. So my opposite operation is going to be division. And of course this cancels out. And what I get here is y equals 30 divided by 0.02, which in fact works out to be 1,500. So that's half of our solution. Okay, so now all I have to do is take that value for y and put it into any equation that we had in the system to find x. So we may as well use the easier one without all the decimals. Okay, so we'll take our x plus y equals 2000 and make our substitution here. So we have y equals 1,500. So we'll make our substitution for the y. So we have x plus $1,500 equals 2,000. So if it's x plus 1,500, if we want to get that x by itself, we need to subtract the 1,500 on both sides, of course. That cancels out. And we get the other half of our solution, which is x equals 500. Okay, so we can answer our question now. Therefore, Nuri invested $500 into the wait, so that was x. So if we go back up here, let's look what we said x is. X is the 8% account. Okay, so we need to make sure we pair the right answer with the right account. So x was the 8% account. And she invested 1,500 in the 10% account. So that's our final solution there. Okay, so exactly the same method, the exact same substitution method to solve this question, but the only difference is we needed to create our own system of equations to start, since it was a word problem. Probably one of the harder questions you'll run into. Okay, so let's do one more example, and that'll be it for this week. It's not a word problem. So let's say here we have solve the following system. And the system is 1/2, actually let me write it like this, 1/2 x plus 2/3 y equals -1. And we'll have y equals 1/4 x minus 5/3. So this is y equals mx plus b form there. Okay, so there's a lot of fractions there, and it looks quite intimidating. But there is a trick that we can do. It'll add one extra step to the solution, but it'll effectively get rid of all of the fractions that we have here. Okay, so what we're going to do for each equation, so we'll say for each equation, oops, can't spell equation, equation in the system, multiply both sides by each denominator's lowest common multiple. Okay, so I'll show you what I mean. So for the first equation, 1/2 x plus 2/3 y equals -1, the two denominators we have there are 2 and 3, right? So what's the lowest common multiple between 2 and 3? Of course, that's going to be 6. And for the second equation, we have a 4 and a 3. So what's the lowest common multiple between 4 and 3? That's going to be 12. Okay, so what I'm going to do now is I'm going to take 1/2 x plus 2/3 y equals -1, and I'm going to multiply everything on this side by 6, and I'm going to multiply everything on this side by 6. And when I do that, of course, on this side, I need to use my distributive property. And it looks a little crazy, but life will be easier, trust me. So this becomes, here, I'll write it like this actually. So this will be 6 times 1 on the top plus the 6 here again. This one's got a 2 there, so I'll carry down my 2. That's divided by 3, and then it's the y. And then, well, negative 1 times 6, we know what that is. That's just negative 6, right? Okay, so I kind of made this a little more confusing, but let's simplify this a little bit. So 6 times 1 is 6. 6 times 2 is 12. But take a look what we've done. What's 6 divided by 2? Well, that's 3. And what's 12 divided by 2? Well, that's 6. And now, look how simple it is. It's just 3x plus 6y equals negative 6. That's way easier than 1/2 x plus 2/3 y equals negative 1. We've simplified it now. Let's do the same with the other equation in the system. This one was y equals 1/4 x minus 5/3. And we said 12 was the lowest common multiple. So times 12 and times 12. Okay, well, 12 times y is just 12y. Not much to do there. But again, on the right-hand side here, whoops, keep doing that. We have to use our distributive property there. So it's going to go there, and it's going to go there. So there's my 12 on the 1/4. It's got a 1 in the numerator, so I got to make sure I bring that down. And it's being divided by 4. And I keep my x there. And then it's minus. So I got my 12 there, but then it's got a 5 in the numerator, so I got to make sure that I bring down that 5. And it's being divided by 3. Okay, well, it's 12y equals, well, 12 times 1 is 12, and 12 divided by 4 is 3. So it's going to be 3x, and then 12 times 5 is 60, and 60 divided by 3 is 20. So now we have a new system. Instead of all that crazy system with all those fractions, we have our new system that's just 3x plus 6y equals negative 6, and 12y equals 3x minus 20. That's our new system. And the solution to this new system is going to have the exact same solution to the original system, as long as you didn't make any mistake. Okay, so let's solve this real quick, and then we'll be done. So here, taking a look, none of the 4 variables that we have here don't have a coefficient. They all have a coefficient, so it doesn't really matter which one we pick here. It's all going to require the same amount of steps. I'll just isolate for x in the first equation, because I can see when I do that, I'm not going to have any fractions. Okay, so I'll take the first one, 3x plus 6y equals negative 6. I'm going to isolate for x, so I'm going to get that 6y out of the way. That's a positive 6y, so I'm going to subtract 6y from both sides. That cancels, of course. So here I'll get 3x equals negative 6 minus 6y. And then that's a 3x, 3 times x. So that means I need to divide by 3 on both sides. and doing so just leaves me with x because these cancel, equals negative 6 divided by 3 is negative 2, minus, again, negative 6 divided by 3 is 2, y. Okay, so that's my first isolated variable. So now, because that x is isolated, I'm going to take all of this and substitute it into the other one I didn't touch yet, which is right there. So this one's going to be 12y equals 3 times everything we've isolated for in the other one, negative 2 minus 2y, and we carry down that minus 20 from up top. And now we can use our distributive property. So 3 times negative 2 gives me negative 6. 3 times negative 2y is negative 6y minus 20. Collect my like terms right there. So, or whoops, not right there. What am I doing? Right here and right here. Those are my two like terms. So I'll just move that negative 6y over. And I got negative 6 minus 20 is going to give me minus 26. All right, so after that, I want to get y by itself, so I'm going to add my 6y here. So that cancels, goes to 0. So I got 12y plus 6y, of course, gives me 18y. Oops, want a thicker one there. 18y equals negative 26. And to get the y by itself, that's 18 times y. So I need to divide both sides by 18. We're not going to get a nice number here. So those cancel. So I get y equals negative 26 over 18. Let's see, that simplifies a little bit. If we divide both those by 2, we get negative 13 over 9. Yeah. Not good, hey? That's fine. So that's our first solution there. So we can go on to the other one. I think I did that properly. Yes, I did. Okay, so that's our y value. So now we can go up. And let's see what I want to do. So I'll take the other one. My, how was it? 3x plus 6y equals negative 6, right? Yep. And I'll take that y value and put it right in there, because that's what y is equal to. So we got 3x plus 6 times negative 13 over 9 equals negative 6. All right. So we can multiply that out. So 6 times negative 13 is going to give us negative 78 over 9. Just kind of gross. Actually, that reduces, I think. Yeah, it does. But I'll do that in a minute. Actually, no, we can do that now. So I believe I can, divide both of those by 3. So if I do 78 divided by 3, I get 26. So that's negative 26, and 9 divided by 3 is 3, so we can reduce that. Okay, so then I'll subtract the negative 26 over 3 on both sides. So then you get negative 6 minus negative 26 over 3. So let's see, we need to make that 6 over 3. So that's going to be what? 8, or no, what am I doing? Negative 18 over 3, right? Because 18 divided by 3, 6. Minus a negative 26 over 3. Oh man. Madness, I tell you. Tough question. Alright, so negative 18 minus negative 26, which is the same thing as saying a negative 18 plus 26. That gives you 8 over 3. And then all we gotta do is divide both sides by 3. Cancels, so you get x. So dividing by 3, that's the same thing as, multiplying by 1/3. So you get an answer of x equals 8 over 9. Oof. So therefore our solution is 8x equals 8 over 9, and y equals negative 13 over 9. Tough question. It's not always going to work out that you get crazy fractions for your solutions, but this was a good one just to show you the kind of questions or the kind of answers you can get. So you have to make sure you're really good with your fraction algebra there. Okay, so we're going to end it there for this week. So for the homework, it started last week on page 425. So for this week, last week I said do 4 to 6. This week we'll do numbers 8, 10, 11, and I'll get you to do question 19A, don't do B, and C. Okay? So stay safe out there, everybody, and I'll see you next week. Bye.